share the PPT and we'll go with our regular class. Where is that? Where is that? Where is that? Yes. Is it visible to everyone, right? Is it okay? Is it okay to everyone? Is it visible to everyone?
Yes, sir.
Okay, thank you. Yes, students, as I as I discussed in the earlier in the, just a few minutes back, soil basic process, mostly you can see this type of things. What are those? You can see the addition of some new materials will be addition, or you can see some deletion, or you can see some losses. Some material may lost from the soil, or you can see some translocation. You can see some translocation means you can see movement of one type of clay, one type of material. Either it may be clay or iron oxides or some ions or minerals, whatever might be. They may translocate it from upper layer to lower layer, sidewards, whatever might be. You can see some translocations. Another one student is called, you can say some transformation, especially the organic matter. Whatever thing you have added, completely it will be transformed by the decomposition process. You can see complete decomposition. You can see there. This is what happening in the these are the things will be happen in the soil forming process. But students, what is the definition? This is what the definition says. It's a process. Students, it's a process. It's a what kind of process? The pedogenic process. It is a pedogenic process. Although show it is very slow in human life, but yet faster than the geological process and changes the lifeless parent material into true soil with a full of life. So it is very slow, but it will works much greater than the geological process, and it turn the lifeless parent material into true soil. It will give a good life to the soil. That means it will give good characteristics to the soil, good physical conditions or some new chemical conditions will be imparted to by this process. And also you can see there will be then this process, in this pedogenic process there is the involvement of some chemical biological reactions will be taken place, and it's very extreme and dynamic process. And also all this process, all this pedogenic process or the or soil forming process will act simultaneously, so, okay, not one by one. All process will act as simultaneously. One process may counterattack the other. Sometimes there may some counterattacking will be there, so one process may dominate with others. So all this we can see. So different process combine operate in the based on the environmental conditions. So different process or different conditions will determine the and will completely depend upon the varying natural environment. So environment will be decide what kind of soil forming processes will be taken place. So what next slide says. So this is what students, as I said very first starting of this lecture, you can see there is a some gain is there. Some material may gain by the soil, or sometimes there is some losing. Some material may be lost by the soil, or you can see some transformation. You can see some transformation, or sometimes you can see the movement. You movement with translocation. That may be like some soil solution form or leaching, or sometimes you can see suspension form. Suspension form is elevation. Students, for your understanding, solution suspension different means if you take some amount of 1 spoon of sand, you just mix in a water, some particles will suspend. That is called elevation. Leaching solution is suspension. That is called suspension. Solution means dissolved components. Like sugar, all are dissolved water, so polar components. All whatever the dissolved components are comes under the solution form. Okay, that movement may be either the movement of materials from one layer to another layer. It is in the form of solution or in the form of suspension. You can expect these two types of translocations in the soil. So what are the form? What are the reactions are taking place in soil forming process? One is gaining of material or addition of material. Another one is lossage. We can see some loss of material. Loss of material means you can lose the clay. Sometimes the upper clay may deposit in the lower layer. And sometimes you can say transformation. Transformation means complete transformation. Organic matter, especially whatever the material, whatever the organic compound we have added to the soil was completely transformed. You can say complete transformation. You can see at the same time translocation. Fourth one is the translocation. Translocation means you can see deposition. It will travel from one part of layer of soil to another part of layer soil. That the transportation will be either through solution, that is, or leaching, or you can say suspension. Both the ways we can be, there is a chance of this translocation will be taken place. This is a very fundamental idea you should keep in your mind regarding with the pedogenic process or soil forming process. Okay. Now we will see next step. What are those pedogenic processes? So very first, students, there are two types of pedogenic processes. Pedogenic processes are there. Students, it is our pedogenic and soil forming process. Both are synonym to each other. Both are same. But while I'm teaching, I may use pedogenic process. But in teaching, I will show this particular. Okay. This. So what are those two types I have said? One is fundamental pedogenic process. Another one is specific pedogenic process. Fundamental pedogenic process means what are they? What are those? You can see humification. Very common. We know, especially it is very common thing which we see. And another one is called elevation. No, elevation you can see. And another part is called elevation. I just my pronunciation may it sounds very similar, but you see the spelling difference. Okay, elevation. To start with I. For your understanding, student, this layer is called washout. It will be below the inside the soil. For your understanding, you can say I means inside. Just remember like that. Okay, humification. Humification, because you're almost what is the meaning of humification. Now we will see what is in detail about these three fundamental pedogenic process. Okay, students. Very first, we will see the humification. What is those humification says? It is completely transformation of sea. Here, transformation is taking place. So it is a complete transformation of raw organic matter into humus. So whatever the material you added in the soil, whatever things you added in the soil, are completely transformed. You can see some changes by the mediation of various microorganisms, and this reaction is highly you know highly completely very complex process. So well, students, in very early stage of decomposition or humification, some simple compounds like starch, sugars will be followed, and followed by some proteins, very simple compounds. And later final stage of decomposition, you can see some resistance component like tannins, lignin, all these things will be digested. And finally we get one complete dark, this type of, it will be look like this complete dark compound called humus. Okay, this complete after for this process is called humification. Okay, students, here we can, in this type you can see some transformation reaction. You can see this is called the humification. Okay, and next we will see what is next. Next is called elevation. Elevation, students, what is elevation? Here you can see some mobilization, translocation reaction you are seeing here, just we have discussed. What are those? Whatever the mineral clay, what are the constant? What are the constant? You can say clay, iron oxides, aluminum oxides, silica oxides, humus, calcium oxide, etc. All these oxides, either in dissolved form, or solution form, or leaching, especially clay, all those things will travel from upper layer to lower layer. So generally there is some translocation is taking place. Generally elevation is called as washout horizon. You can see washout horizon. You can see all the complete components may go through either from suspension, that is leaching, or solution by the percolation of water. Some percolation of water from upper to lower layers. From this upper to lower layer, we can say in this origin generally we will represent in most of the pedology we represent as E origin, but in old some another notation is E2 horizon. Okay, the elevation is encompassed mostly, we can some mobilization will be there and translocation will take in place. Mostly this horizon is completely termed as alluvial horizon. In taxonomy we will talk it as this horizon, will talk as elevation horizon. Complete leaching will be there, washout, complete washout will all clay materials, all the oxides, all silica oxides, everything was completely washed out in this elevation. And this is for SRF students. Students, you please remember this is the notation A2 and E origin. Generally, I think A2 is old notation, E is new notation. There are two types of notations are there for giving symbols for the layers. This is A2 and this E origin. This is especially remember this. Okay. And translocation complete depend upon what are the factors, complete depend on the mobility of the element and depth of the percolation. So these are the major guiding factors for the alluvial procedures. Okay, elevation will take in place like this. And next, coming to the next thing is elevation. I means inside. Just to remember, I means inside. Just keep it for understanding. Okay, this process here you can see some deposition. There you see some translocation, but here some addition is taking place, that is deposition is taking place. Okay, soil materials. Now whatever the materials are removed from the alluvial horizon was completely deposited in this horizon, alluvial, this horizon, elevation horizon. So this origin was formed by the depositions of the above alluvial horizon. So the alluvial means generally this is noted as BT horizon, students. Especially SRF students, you should be very careful. They may ask like this, what is the BT origin like that? Please be very careful regarding with this. B origin is okay, everyone can say, but you should be very careful. BT origin, okay. The term alluvial origins, the process lead to the textural contrast. So due to this deposition, and you can see there is a lot of textural difference. There is a textural contrast will be there in E horizon or A2 horizon and BT horizon. And there will be some greater difference, like higher fineness to total clay ratio. There will be more clay in our alluvial horizon because all the deposition will take in place. Like this, you can see a lot of depositions we can see, and the darker color variations you can see easily you can identify in the alluvial horizon. So this is another important fundamental pyrogenic process. And finally, students, these three things will lead to the development of some horizons. So what is a horigination? So we get different properties. What is this horigination? It is a differentiation of soil in different origin by depth in the soil body. Mainly this differentiation, how this differentiation, just for example, students, horizon means, so for example, this is the, we have dig one big horizon. Generally what we'll see, very top layer, generally it is a horizon, or you are in some temperate or in a very forest area, you can see some other thin layer called O horizon, that is organic horizon. Later you can see some A, or sometimes due to the elevation horizon you can see some B, some again you can see some transformation of I horizon, again B, you can see B, and again in depth you can see C, and finally you can see some last R, and finally at the depth you can see bedrock. There will be some unweathered bedrock will be there. So this is the horizon. So this differentiation here, generally O will be something somewhat very dark, and A is some will be the, in A also there are different types is there, students. In A there is a plow layer is there, non-disturbed layer is there, that is we will discuss in horizination level. Actually for JRF students no need of that much, but SRF students you have to learn all those things, okay. Coming to that A, after you can see some B, some E you can see there, and after you can see some I you can see there, or sometimes I can't say I, it's a BT, and later you can see some C and R, and finally you can see some bedrock. So this differentiation is due to the effect of this fundamental pyrogenic process. Like students, this fundamental pyrogenic process, like this humidification, elevation. So due to these three processes, you can see this differentiation. And also there are another thing of fundamental specific pyrogenic processes are there. The specific pyrogenic process will give very specific and very definite properties. Some very specific properties will give to the soil. What are those? How those properties are influenced in the soil? We will see all these things in the coming slides. So this is regarding the fundamental pyrogenic process. Is it clear, students? Very fundamental today. It's very fundamental. Okay. Is it clear? Shall we
Yes.
move to the next slide?
Yes, sir.
Okay. We will move to the next slide called specific pyrogenic process. Okay. Sorry. Okay. You can see next is the specific pyrogenic process. So there are two types of, as earlier I discussed, there's a fundamental pyrogenic process, and second one is called specific soil forming process or specific pyrogenic process. So generally, how many types are there? What is the framework is lateral operation? So generally, this the fundamental pyrogenic process, basic pyrogenic process will give some platform or some framework. They will arrange some framework. Upon this framework, this specific pyrogenic process, that means it will give some base. Fundamental pyrogenic process, it will give some basic base for the specific pyrogenic process. And how many types of specific pyrogenic process are there, sir? We will see. Very first one is called calcification. The word itself, it says it is the deposition of calcium. And another one is called decalcification, paka opposite to this one. Okay. And next is called fossilization. What are those? We will see in the coming slides. And next one is called lateralization. Generally, mostly I think most of you are from very old universities. If there definitely you may see this stone, lateral stone. Okay, you will see all those things. And next one is called gelialization. If any if anybody have see this is very hard impossible. It is very difficult to for us to see this origination. Mostly we can see some in India we can see Uttarakhand, Jammu Kashmir, there we can see this type of things. And salinization, very quite common in certain states. And next is called desalinization, opposite to this. And another one is called salinization, alkalization. We will discuss about this one also. And later is called Pedoturbation. Generally, we will see these turbations mostly you can see in the twist to expanding type of clay minerals. Then that part, or sometimes this animals and other factors also will contribute this pedogenic process. And next one is called solidization or dealkalization. Okay, solidization or dealkalization, opposite to this one. So like this, we can see these are the different specific pedogenic process. Okay, students, please first of all list out what we should know how what we are reading today. Okay, this is called the calcification, decalcification, lateralization, podzolization, salinization, gelilization, salinization or alkalization, desalinization or solidization or dealkalization, and pedoturbation. So these are the terminologies. Okay, students, please note down. Please make some note on all these things. Okay. Now, one by one, we will discuss what are those things, how this happen. Calcification. Okay, students, the word itself it says about the calcification is nothing but accumulation of calcium carbonate. That is what mostly these accumulation mostly in the tropic zones, same as tropics and semi-arid zones. Semi-arid zones, we can observe this type of calcification. Mostly, I think gypsum, all the availability of gypsum or carbonates, everything we can see in our Rajasthan. You can see all those things. This type of reactions are very quite common there. So it is nothing but accumulation of calcium carbonate may the result of development of calcic origin. So especially SRF students, if this calcification, wherever the calcium was deposited, that origin is called as calcic horizon. Please remember these words are very important. Calcic horizon. So calcium, naturally this calcium was readily soluble in water. But what will happen means when the concentration of CO2 is high in root zone, what will happen? You can say there's like a production of some carbonic acid. Again, it will combine with the calcium. We can say calcium carbonate. We can calcium bicarbonate. We can see again this was divided into precipitates. What are those precipitates? Calcium carbonate plus water and carbon dioxide. So the process of this precipitation, what will happen? This reaction, this complete reaction is called nothing but is called as calcification, students. And generally this was denoted as bk horizon. Bk is old notation, bc is new notation. Sorry, bc is, I think, I want to confirm, student, I think this is a old notation, bca. Bk is new notation. This is like this we will give notation. These are the notations for the horizon. So bk and b horizon. As our students, so please be careful. This is for your information. I incorporated here. So this is a process of precipitation after mobilization. It's called calcification. Completely this after deposition of these precipitations, you can see like this. See in this image, you can see some white color precipitations. You can see. So these precipitations is this layer is nothing is called as calcic origin, or you can say calcic origin. Okay, this is notated as BK horizon. Okay, student, this is regarding the calcification. Coming to the next, decalcification, opposite. Opposite term. Opposite. So here you can see calcium carbonate, again it was reverse reaction. And what will happen? The calcium bicarbonate completely it will be dissolved and will be removed. Everything, all the calcium were completely washed out. Nothing it will be there. So there is a no problem of calcification. There is no calcium layer is present in the soil. This is paka opposite to our previous slide. Okay. Coming to the next. What is the next? Podzolization. You know, podzolization is nothing but apart from calcium, except calcium, all the bases were completely removed and complete soil will become very distinctly acidic. You can see very low pH because everything was leached out. Everything, all the bases were completely leached out. Apart from calcium, everything was leached out. And what will happen? You can see the pH was completely increased, completely because everything was removed. And this leads to the development of podzels. So this is called this formation is called podzels. And generally, if you want to say this podzolization is negative of calcification. Calcification, what will happen? Tends to concentration of calcium in the lower part of the horizon, whereas podzolization leads to the entire column of calcium carbonates. Leaches the entire column of calcium carbonate. Apart from calcium, almost all the bases were completely leached off. So we can see there this process is called the podzolization. It's completely so there is no basis, nothing is there. So what will happen? With all the base saturation zero means what will low means generally the pH is very high. So the complete horizon or complete horizon will become very low, completely horizon. And coming to the next one is called what are the favorable conditions we can see. This is what very important, students. Climatic conditions should be cold and humid conditions for the if you want to get the porcelarization, there should be a cold and humid climate will be there. And what kind of parent material should be there? We should have some silicaceous sandy material, heavy pore reserves of weatherable minerals, and we have a very sandy silicaceous material. We should have having a poor reserves of weatherball minerals. What kind of vegetation? We should have some acid like coniferous trees. We can see some. We should have some coniferous trees, and also some SQ oxides. The process of decomposition, what will happen? Various organic acids are produced. So these organic acids, what will happen? Again, they form act upon SQ oxides and remaining clay minerals, forming organic SQ oxide, organic K complex, which are soluble and removed in the percolating water to the lower orders like BS and BH. So like this, these SQ oxides, leaching, and all these organic compounds, these are the favorable environmental factors which supports the fossilization. Please remember this. We should have a cold and humid climate should be there. Sandy or silicaceous parent material should be there. Coniferous trees. That means we should have some acid producing things are there, and also leaching of translocation of SQ oxides. SQ oxides, all the iron oxides, everything was completely all the silica, iron oxides, everything was leached out. Why? Because of this thing, this organic SQ, because of this organic acids decomposition. These acids will be released, and those acids will attack on the SQ oxides, organic clay complex. So what will happen? They are removed into the lower origin. They move to the lower origin. These are the favorable conditions for the fossilization. And coming to the next, coming to aluminum also, students. These acidic conditions, aluminum also contribute something. Some indirectly it will contribute to the acidity of the fossils. What are those? When aluminum was combined with H2O, what will happen? Aluminum hydroxides will form, and there will be a release of H plus ions. That is why in acid soils, aluminum is indirectly contribute to the acidity in acid soils. So aluminum also is one of the problem. Okay, as iron, generally what will happen when the iron and aluminum was completely leached out? What we can see? We can see some grayish layer, grayish and ashy coating. We can see in that layer. So those layers are called. It will looks like this, students. We can see some ash coating, or sometimes we can see bleached gray layer. You can see, if you see this type of layers, we can say those are the podzols. Generally, podzol means in Russian word, you can see means zola means ash. You know, pods means under, zola means ash. This is what Russian. So under ash, so it will give some ashy coating surfaces. Okay. So this is the
Sir, sir,
yes, 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 yes.
I've heard that podzolization is also called acid hydrolysis.
Yeah, that is what happening here.
So, what's the hydrolysis process here?
Hydrolysis means, yeah, you can see here. You can see aluminium and H2O. You know, the both are water was dissociating into two H plus, and some additional oxygens are there. So aluminum hydroxides are coming, and H plus ions were releasing. This reaction is called hydrolysis. You can see you can see some splitting of water molecules here. This is the reason it's called that name.
Yes, sir. Is that due to acid?
It's a leaching, ma. What is happening in fossilization means
Uh,
complete bases were completely leached off. There no bases are there apart from calcium. Everything was leached out. There is no silica. There is no iron. Nothing is there. So what will happen? The pH is very high. The pH is very
yes,
high
sir.
means solubility of aluminum was very high. So this aluminum
Okay.
completely react with water molecules. Water is dissociated in a low pH. Water was dissociated into two OH and H plus ions. Aluminum will combine with hydroxides, aluminum hydroxide. Excess H plus ions will release it to the soil solution. So naturally, what will happen? As the iron aluminum was completely moved above, and what will happen? It will give some ashy appearance, ash coating appearance like this, just as shown in the image. That is what the reason there.
Okay.
And also, mostly this fossilization will prevail in cold and humid climatic, and where the coniferous, just we have discussed in the previous, you can see coniferous and acid forming situations are there, and the humus SQ oxides become more mobile and leached out from the upper horizon to deposit to lower horizon. So only remember, so fossilization means complete dissection. There will be no basis will be there, everything will be completely leached off. All soil was completely become acidic. So acidic means generally what will happen, the solubility of aluminum is very more. So then in acidic condition, what will happen? There will be a dissociation of water molecules will take in place. So H plus and OH minus are very plenty availability is there. The aluminum will join there. Actually, this reaction is always very quite common in acid soils. So in management of acid soils, aluminum management is very important, especially in Bhubaneswar or in Odisha conditions where the heavy leaching and a lot of rains are there. 80% of soils of Odisha is completely acid soils. So this reaction is very quite common in that conditions of soil because of this particular specific pedogenic process. Sometimes you can see because of heavy leaching. Okay, students, this is the reason. This is the regarding explanation regarding the fossilization. We will discuss in next is called lateralization. This is what. So how many are from very old universities? I mean, very old before independence colleges. How many are coming from that? Hello. Okay, I think Ramya is there.
Okay.
Ramya, have you visited to the Coimbatore main campus?
Yes, sir.
Have you seen the old buildings of police station in Tamil Nadu or collectorate buildings of old buildings?
Yes, sir.
What are the color of those buildings?
Brown color.
Brown, light. You can see this type of color, brick color.
Yes, sir. Yes, sir.
Do you know what is the reason for that?
No, sir.
That is the laterite stone. Those days the buildings was construction as used laterite stone. If you observe very keenly inside that laterite stone, you can see some honeycomb like structures. You can see even if anybody even very old universities, even I think IRI building also is constructed by those laterite buildings, old buildings during the British period. All those things. In Uttar Pradesh also many universities of old universities were complete in those days. They used this laterite stone. This laterite stone was formed due to the due to the why, because of this lateralization process. What is this lateralization? What is all those things? We will see now all this. Okay. uh, it is nothing but it's a brick or tile was originally grouped in mostly. As you can see this found, you can found this type of laterite or laterite brick. Laterite means the word meaning is brick or tile, originally applied to the group of high clays in Indian soils. Mostly you can see Malabar hills, especially in Kerala. You can see Tamil Nadu, you can see Karnataka, Maharashtra, and few parts of Bhubaneswar also you can see, but not that much. Very less part you can see, and it refers to specifically to a particular cemented horizon. So here what will happen is, okay, and directly I'm coming to the point. What happening in lateralization process means, in this process that removes the silica. Instead of sesquio oxides from the upper layer, they leave the sesquio oxide construct in the soil. What will happen means entire silica was completely leached out and leaving this sesquio iron oxides. So all these iron oxides were completely was left out. What will happen? Sesquio iron aluminum oxides were completely left out in this soil, in this solum, in this horizon. All the silica was completely leached out. So what will happen? It will give the distinct color of this oxide color, this brown or reddish color you can get. So when this was exposed to the outer environment, outer atmosphere, it become very hot. So these bricks were used for the constructions in those days, but nowadays no one is using. These bricks were used in old days, even for the construction of many monuments, very old buildings, especially TNU main building is you can see this type of stone. In Odisha University, OAT compound was completely constructed by this bricks only. OAT, that complete agriculture block was completely compound was completely constructed by this bricks. Even hostels were constructed by hostel compound was constructed by this bricks only. And some old colleges, like you can see this type of bricks. And if you see very close, you can see some honeycomb like structures you can see in this laterite stone. So this lateralization is process nothing but, students, here the silica was completely leached out. Only iron oxides means iron and aluminum oxides. That's called sesquio oxides, completely present. Almost 70 to 80% of total mass is only completely this laterites. And more we can see laterites. Sometimes the soils are completely comes under the oxysols. You can see. You will read all those things in the coming classes. And taxonomy, you will read all those things. Okay. This is regarding the lateralization process. You can see next. What is that? What are the supporting conditions? Mostly climate. Hardly if we get 2000 to 2500 millimeters of rainfall, continue the high temperatures of 25. Those are the favorable climatic conditions. Mostly warm and humid conditions should be provided. And what are the vegetation? The rainforests, tropical areas are favorable for the process. And what kind of parent material should be there? So I guess mostly it should be like a iron-bearing ferrous magnesium mineral like pyroxenes, amphiboles, biotite, and chlorides. SRF students, you should know all these things. What is chlorides? What is amphibials, biotides, and chlorides? JRF students, you should have very fundamental know. What you should know what is these names first of all. Later you go to the conditions. Okay, which are weathering. Whenever these components, pyroxene, amphibials, biotide are completely weathered, what will happen? There is a release of iron from these components. and congelated and developed laterites. Completely, they will congolate, they will combine and form the laterite stone. That is, this is mainly called as this is called the lateralization. In porcelainization, what is happening? Their silica was left out, and all the aluminium, etc., etc. Sorry, calcium, all the bases was completely leached out. So that is a process there. In lateralization, all the ferromagnesium, this iron and aluminum oxides were left out, and all iron oxides were left out in the horizon. All the silica was completely leached out. That's why we're getting this type of brown and reddish color. This is regarding lateralization. Now we will see generalization. Actually, generalization we can't observe much and many more. Only in submerged conditions where the you know the we can where the poor drainage conditions are there, more waterlogging process, waterlogging conditions are prevailing, highly waterlogging prevailing. You can see this type of generalization. Mostly very submerged conditions where there is a very lowland areas, especially you can see this type of conditions. Generalization is a process forming of gilgite. We will learn students gilgite. What is gilgite? Gilgite means clay horizon. You can see gray and clay horizon in the lower part of the profile. Due to this condition is prevail due to this condition. This color is due to the because of very poor drainage conditions and waterlogged conditions. So soils are called are also called as the hydrophilic soils. So the another name for the soil. This generalization. This type of soils are called as hydro or quick soil. The process is not particularly depend upon the climate. Mostly we can't say we can't say it's a particular climate. It's completely depend upon the drainage conditions. Only in submerged conditions we can see this type of conditions, especially lowland conditions. Whenever if you dig a profile properly, you can see this type of jelly, like this type of gray origin, this type of gray origin you can see. So we will see what is the conditions of river. So this is the conditions. Poor. What is happened? Lower topographic positions. Just now I said, now lower topographic position, depressed area, because that is the area where complete water was stagnated. You can see because there is stagnated water will be stand there. And another condition is impervious soil, soil parent material. There is no infiltration. It was very high impervious parent material prevailing. We can see some proper drainage conditions. There will be no aeration will not be there. And also under such conditions, what will happen? Iron compounds are reduced to soluble ferrous compounds. What will happen? All the iron components will completely dissolve and soil become a ferrous compound. Ferric compounds completely different to ferrous compounds. Okay. So the reduced of iron primarily biological, both organic, micro, and capilla, respiring anaerobically. Completely go anaerobically. The solubility of all our minerals, calcium, magnesium, iron increases. Most of the iron will exist as Fe2 plus or it forms some complex with the solution and mixed precipitation convert to ferric precipitate to complete mixed precipitates. So we can see some mixed precipitates of ferric and ferrous hydroxide. So mostly all this unconditioned, all these conditions completely leads to the formation due to this ion complex with organic compounds, and we can see some mixed precipitates of some this ferric and ferrous components, and some biological 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 consumption of this iron by primarily by microorganisms by anaerobically. All these conditions leads to the formation of bluish to grayish horizon with a mottling of yellow color or reddish brown color. Especially students, if you have, I have seen personally, I have seen this mottling of yellow color in my PG studies. When I was reading my post graduation, I have digged one profile in lowland area, especially in Pondicherry, Union Territory of Puducherry. It's called as Karaikal. We have seen one profile. I have seen lively. I have seen this yellow color models and some grayish. You can see some grayish brick colors. I have seen that models. I have seen or some even this reddish browny colors we can see. Those all those small because it's a lowland area. Water was all whenever the rain comes, heavy rain comes, completely submergence will be there. The respiration was very less. So what will happen? You can see this type of bluish and grayish horizons we can see. Okay, students, this is what happening in this is the conditions. These are the conditions if the drainage was very not properly maintained. Coming to the salinization, it's very easy. Hardly speaking, in future classes, definitely you will get a one special class regarding the salinization. All these things, because all this you will read in the problematic soils. Very important regarding your examination purpose. Most of the questions will come from the problematic soils. How to manage the problematic soils? What are the conditions? What are the physical conditions? What are the chemical conditions? Very interesting chapter in the soils and all those, because that is a real type of management in agriculture. It's problematic. Anyhow, coming to the class students, salinization is nothing but called, it's a salts of sulfates, it's a salts of sulfates and chlorides of, it's accumulation. What accumulation of sulfates and chlorides of calcium, magnesium, sodium, and potassium in the soil. will forms the salic horizon or salty horizon. Salic horizon is very professional. Remember this word. Okay, you can by the accumulation. Accumulation of the salts will form the sulfates and chlorides of calcium and magnesium. Mostly this type where you can see students, mostly you can see arid and semi-arid regions. Why, sir? Why this happening? Why this happens? Say for example, students, this is your land. Okay, it is completely soil. These are the horizons, all the horizons, all everything is there. In down there is water. Water is there. Groundwater is there. All your sulfate, these sulfates and all the salts, calcium salts, magnesium salts, your sodium salts, and potassium salts completely here. What will happen means due to the in semi-arid region there is a temperature is very high. There is evapotranspiration is more. What will happen? This water, whatever the dissolved components, will move to the upper layer. All these components will move to the upper layer due to the capillary fringe. You can say due to the capillary action or due to the high evapotranspiration, due to the high evapotranspiration in the upper layer, what will happen? All these salts were completely accumulated in the upper layer. So what will happen? Finally, we can see the end up we will end up with problem called salinization. You can see some sort of we can see finally we will end up with salinization. So this raise especially, and also students, there is one more reason called nowadays we can see seawater intrusion, especially coastal regions of coastal cities like nowadays I think Kolkata, Vishakhapatnam, even Chennai. You can see all these cities are facing a new problem called intrusion of seawater. Some seawater was completely undergoing into into the suppose, so this is, remember, this is our India. Okay, I think here somewhere it will be Kolkata, here Vishakhapatnam, and down somewhere we can see some Chennai. Even for example, you can go to the Mumbai this side. What will happen means sometimes you can see water intrusion. You can see seawater intrusion. Maybe some due to the tidal waves. Sometimes the tidal waves may influence directly involve in the salinization of the soils. Sometimes what will happen means the underground water will be removed for the consumption purpose. What will happen sometimes? The depleted area will be replaced with this seawater. And what will happen in some agriculture contaminant area? This water was pumped out and used for the irrigation. So what will happen? Those soils are completely end up with the salinization. This is a new problem, students, nowadays. And this tidal water influence is due to the because of destruction of mangroves. Mangrove forest, especially in I think in Andhra Pradesh, even West Bengal, especially in West Bengal, you can see this mangrove forest. Mangrove forest really control the salinization problem. It will stop the tidal water entry into the mainland, especially and in southern India, in Tamil Nadu, you can see this Kadalur district, especially Pichavaram. There is one area you can see, and also in Bengal, West Bengal area also you can most of the West Bengal area you can see this type of conditions. So if it is due to the heavy urbanization or due to this fishing, some inland fishing, nowadays they're chopping up, they're removing the mangrove forest. Due to this removal of mangrove, what will happen? The seawater was coming into the mainland, and all the agriculture fields were completely turned into saline soils, completely salt affected soil. This is a major problem, especially facing in the coastal agriculture regions in entire coastal India, from Karnataka to from here Maharashtra to and completely here West Bengal, everywhere this problem is prevalent because due to the heavy urbanization, some unplanned commitments, all this thing leads to the many problems. So these are the reasons, and no problem, students. You will learn many things regarding that issue, especially the salinization. You will learn many things in coming classes. Coming to the next class, next subject is called desalinization. It is nothing but leaching off, students. Complete leaching off. You can see whatever the dissolved salt, whatever the salts will come completely. What will happen? Excess salts are leached out from the content, and what will by the proper drain, by providing proper drainage or by giving some artificial drainage network, all the salts were removed. The removing of salts is called the desalinization. And alkalization, alkalization or salinization. This is nothing. This is a major problem, students. The sodium domination. Don't confuse today alkalization regarding the previous salinization, salinization, whatever might be. Here you can see the dominance of sodium ions. In clay complex, you can see more amount of sodium dominance. So what will happen whenever there is a high exchangeable sodium percentage is very high in clay complex means what will happen? Anybody idea? Can anyone say? The sodium content was very high. in the soil or in the clay complex, what will happen? What are the problems you will face in general? You should say. Anyone can say.
Questions.
What, ma? Please discussion. And it is a. Please, we can say what happened if there is a more sodium ions in the clay complex. What will happen?
Breakdown of aggregates.
Yes, aggregates will be. There is no proper aggregate will be there because
Water
sodium is
stagnation.
a
Dispersing agent.
dispersing agent or deflocculating agent. Okay. Yeah.
Deflocculating agent.
Yeah, deflocculating agent. Okay. So there will not be any proper aggregates will not be there because sodium is the deflocculating agent. Any other region? Any other problem other than this? Osmotic imbalance will be there. Uptake of nutrients are very less. When there is a high amount of sodium is there in the clay complex, we can see. So naturally, you will face all those problems. Anyhow, you will read about these two. These two concepts are very interesting. You will go in detail regarding in the future lectures. So how this reaction will taking place means what will happen means all this sodium, all this calcium, magnesium, sodium, everything will convert into sodium carbonate, magnesium carbonate, calcium carbonate. What this acts mostly acts with completely organic compounds. So it was complete replacement. All the sodium was completely came in the exchange as completely sodium was dominated means we will see some problem called alkalization or salinization. Or we can the soils is called alkali soils or sodic soils. Coming to solidization, opposite students, dealkalization. It's a removal process, a removal of sodium from the exchangeable soils mostly. Okay, students, in sodic soils or alkali soils, what should we do to remove the sodium? What should we do? What should we do? There is the sodium is very high, students. The soils are considered as sodic soils. So what should we do now? What kind of management we can give?
Gypsum application.
Gypsum. Okay. Gypsum, is it right? Everyone should answer, not only one student. Everyone should participate. Okay. Gypsum should be applied. So this is called the solidization reaction. So solidization nothing but just removal. So what will happen, students? Much and much this when this was replaced, a dispersion can be eliminated by the calcium and magnesium ions, which is used to least soonest. By when we replace with calcium and magnesium, what will happen? There will be proper aggregates will be there. All the physical problems completely calm down into normal conditions. So that like that you can see many favorable conditions. That's why you can go for gypsum. Sorry, yeah, gypsum application. Okay. Next, pedoturbation. Pedo means soils. You can just soil moving. Soil mixing. You can see the mixing of soils. Pedoturbation is called nothing as mixing of soils. We can see complete mixing of soils. Okay. At the same time, this pedoturbation will taking place by many things. You can see the mixing you can see by the animals like ants, earthworms, rodents, sometimes rats, moles, we humans also because we are plowing the soil like this. So that is called the funnel pedoturbation. And another one is called floral pedoturbation. Flora means plants. So generally plant tippings, sometimes plants mixing of plant tips may sometimes mix the soils by extending their roots. The small rooty hairs also will contribute something to the mixing. And argillic pedoturbation means nothing but swelling and shrinking. Mostly you can say the swelling and shrinking in black cotton soils because of expanding clay types, especially 2:1 type of expanding clay types. You can see this type of pedoturbations. So I think you can see that especially you may not observe all these things, but definitely you may observe this pedoturbation in black cotton soils. Whenever there is a summer season, when there is a no rain, all big cracks you can see. And all of a sudden, when the rain comes, what will happen? You can see some mixing, all the bulging will be so this contraction, extraction. What will happen? You can see some changes in the layers. There will be mixing will be taking place. This period turbation is mixing. All this mixing will be taking the turning of the soils will be taking place. This is one type of specific pyrogenic process. Anyhow, overall, these are the important pyrogenic process, and especially yesterday, students. I think previous class this. Topography while we're discussing this image I forgot to add to you, but today I'm showing. Here you can see in upper part of the soil, where the upper region you can see poor soils you can steep stuff, very little infiltration will be there. So whatever the soil completely eroded. In average soils, here we can some gentle soil. So some you can see some amount of filtration. The loss of erosion was very less. But here in down you can see great soil, you can see very good flats, very good infiltration, you can see very good depositions are there, highly fertile soils will be the infiltration will be the very good conditions are there. So this entire difference of origination is known as, I said, you should say, what is called as?
Soil ketana.
Soil katina. Yes, soil katina is called as soil katina. Anyhow, I forgot to add this image. That's why today I'm showing to you all. Anyhow, students, hope that's all. Very thankful for your patience. Again and again, I'm saying, be sincere, maintain this tempo. Go, please maintain some sincerity. Be sincere in your preparations. Definitely, you will get a good rank, good college. Once you get a good college, it's very nice. I hope. Definitely, you are also now studying in very nice universities. But you need to some change. Don't read in one university more than degrees. You just just change and have a good life. Thank you very much, students, for your patience. Please attend all classes, all live classes. Then only it will very good. YouTube class, okay. Recorded classes, okay. You can listen, but it won't be that much lively, okay. Anyhow, thank you, students. Be sincere in your studies. Okay. Thank you very much. If you have any doubts, we can ask. Any doubts, you can ask, students. For the first time, I'm getting 5 sessions. Okay, regular presentees are okay. Miss Rai, Ramya, Vedavyas. The only student yesterday is going to present the class is Vedavyas and Varun. Okay, very good. And Abhishek. Abhishek, is this for your first class?
No, sir, it's second.
Second class. Please,
Yeah.
students, don't be irregular. Come to the live classes.
Sir,
Please.
actually, we are lab students and we are busy, a bit busy in submitting the records and attending the
Okay,
Viva.
okay. That's why we have asked now. When is your convenient time? You say that time. You will say. I think SRF students, we have no problem. All your research is going very properly, right? Please, if you have such kind of problem means, please inform me. Please, we can discuss in the WhatsApp. Which timing is very good, which time is better for everyone. Then we can be okay. I think SRF students, is your
Yes.
research is going on? Yeah, yeah. Is your research is going on? I think it's lockdown. Everything is going well.
Hmm?
Is going well.